began quietly, almost too quietly. For weeks, astronomers around the world watched 3i Atlas glide toward the sun, slow, calm, and predictable. Just another cold traveler from deep space. Nothing more, nothing less. A frozen wonder passing through our neighborhood before drifting back into the dark. And for a while, everything looked normal. But space has a strange way of hiding surprises in silence. As the comet moved along the ecliptic, the first observation logs started to arrive. Data sheets, brightness graphs, temperature readings, routine numbers that scientists see every day. Except this time, something didn't fit. Something small. Something subtle. But once you saw it, you couldn't unsee it. The light curve was wrong. Not a little wrong. Not we need to check the telescope wrong. But impossible wrong. Atlas brightened and dimmed in sharp steps, almost like it was switching between two states. No smooth transition. No natural curve. Just sudden jumps that felt closer to a pulse than a reflection. Astronomers stared at their screens in silence, wondering if they were witnessing the first glitch in a very long night. Some blamed faulty sensors. Others blamed scattered light. A few even blamed tired eyes. But when the same strange pattern appeared again and again across different observatories, in different countries, using different instruments, the excuses fell away. This wasn't noise. This wasn't a mistake. This was the beginning of something that did not belong in the natural sky. A cold object shouldn't pulse like this. It shouldn't behave like it's responding to something. And yet, 3i Atlas continued its slow drift toward Perihelion, carrying a mystery inside its glow. If the edge of the solar system already feels strange, then what's waiting for us closer to the sun? At first, the flicker looked harmless, like a tiny heartbeat lost in the darkness. Most comets brighten smoothly as they fall toward the sun. Dust lifts, ice turns to vapor, and the glow grows in a gentle, predictable curve. It's one of the simplest rhythms in astronomy, a rhythm that every student learns on day one. But 3i Atlas refused to follow that rule. Instead of rising in a calm arc, its brightness jumped, sharp, sudden, and unnerving. A spike, then a drop. A flash, then a pause. As if someone out there was turning a dial, testing the lights, adjusting the stage. And the deeper you looked, the stranger it became. Across continents, telescopes captured the same uneven rhythm. Observatories in Japan saw it. Then Chile. Then South Africa. Each one recorded the same strange step pattern. Bright, dim, bright, dim. Not drifting like dust. Not tumbling like rock. But switching, clean, controlled, almost mechanical. One astronomer compared it to a lighthouse lost in space. Another said it felt like Morse code with missing pieces. Most didn't know what to say at all, because everyone could see the truth forming between the numbers. This wasn't a natural light curve. It was a behavior. A frozen rock doesn't pulse like this. It doesn't decide when to brighten or fade. It doesn't show the kind of symmetry you only see in engineered systems. And yet, night after night, Atlas flickered in the same precise rhythm, as if following an internal clock. The anomaly grew louder, first in quiet labs, then in astronomy forums, and finally across private emails where scientists whispered questions they didn't dare ask in public. What if it's not reacting to the sun? What if it's reacting to something else? Because the deeper the object fell into the inner system, the more the flicker tightened into a perfect pattern, like gears turning, like circuits warming, like something waking up. So why does a frozen visitor behave like a machine? And what happens when that pulse reaches its peak? Not the entire world, just a tiny part of it staring at computer screens, waiting for the next reading from 3i Atlas. Teams in Asia were watching. So were teams in Europe. And in South America, a small observatory perched on a cold mountain kept its lens locked on the wandering object. 3 continents. 3 different skies. 3 different machines. And yet, they all saw the same thing. At 2:14 and 7 seconds Universal Time Coordinated, Atlas flashed. Not a slow rise. Not a dusty eruption. A single, sharp pulse, clean as a metronome strike. Most natural objects brighten gradually. Even outbursts follow messy physics. Dust clouds, uneven jets, chaotic scattering. But this was too perfect. A millisecond long spike. Bright enough to trip sensors. Fast enough to confuse them. The moment the timestamp loaded onto the screens, every researcher froze. Emails flew within minutes. Screenshots, light curve overlays, log files with the same haunting number. 2 hours, 14 minutes, and 7 seconds. Everywhere. Different telescopes don't sync like that. Different hemispheres don't align that neatly. Nature doesn't press send at the exact same second. So what did? One astronomer in Tokyo whispered, almost afraid of his own voice. "This looks like a signal." Another in Italy stared at the pulse pattern and asked quietly, "Signal from what?" And in Chile, under a freezing sky, a young researcher replayed the brightness spike again and again, each time feeling a strange chill run down her spine. The pulse wasn't random. It wasn't noise. It felt intentional, like a knock on a cosmic door. A pulse that should not exist, now existed. A message that should not be possible, had been sent. A quiet, perfect flash traveling through the ecliptic like a whisper carried by light. If the universe is truly silent, then who, or what, is speaking first? And if this was only the first pulse, what comes with a second? The first thermal readings came in quietly, almost hidden beneath the noise of the previous night. Just a few numbers, a few tiny blips on an infrared chart. But the moment scientists lined them up, something felt wrong. 3i Atlas was warming. Not the normal kind of warming you expect when an object falls toward the sun. Not the gentle rise you can explain with distance, sunlight, or melting ice. This was different. This was alive. Every few hours, the temperature rose, then fell, then rose again, like breath moving through a sleeping body. A slow inhale, a slow exhale. Heat, cool, heat. No comet has ever behaved like that. Astronomers check their instruments. They check calibration logs, environmental data, atmospheric conditions. They blame thin clouds, stray reflections, even software bugs. But the numbers didn't move. Even when Atlas entered total shadow, when not a single photon from the sun touched its surface, the heat pattern continued. Rising, falling, rhythmic, intentional. It was as if the object was regulating itself. One researcher stared at the readings and whispered, "Rocks don't do this." Another asked, "Then what does?" The thermal map, usually a messy smear of random warm and cold patches, formed something terrifyingly organized. Perfect bands, clean gradients, smooth transitions that looked more like engineered cooling systems than natural ice. Some compared it to a running engine. Others said it resembled the thermal signature of a machine preparing for operation. And as Atlas drifted deeper into the inner system, the breathing pattern grew sharper, almost like it was adjusting to the changing environment. It ignored sunlight. It ignored shadow. It ignored every rule a comet should obey. This was no passive traveler. This was something that reacted, adapted, compensated. Something that behaved like it had a purpose. So what kind of origin produces an object that warms itself, cools itself, and follows no law of nature we know? And if this is only the beginning of its awakening, what happens when it starts acting with intention? At first, the light looked normal, just sunlight brushing across a drifting body. Nothing strange, nothing alarming. But then the reflections sharpened. Instead of scattering in soft, dusty clouds like every comet we've ever seen, Atlas began bouncing light back in clean, razor-thin angles. Not glowing, reflecting. Not shimmering, redirecting. It was the kind of precision you see on polished metal, not on ancient rock drifting through the void. The team in Hawaii noticed it first. Their instruments caught a sudden spike in brightness, a flash so sharp it looked like a mirror catching the sun moments later. A European observatory recorded the same thing, a beam cutting straight across its detector like a thin blade. Albedo numbers climbed, higher than clean ice, higher than crystalline frost, higher than anything that should exist on a rough, frozen boulder from another star. It was almost intentional. As Atlas rotated, the reflections followed a pattern. Bright, dim, but not in the soft, rounded way natural surfaces behave. These were abrupt transitions, like panels catching the light at just the right angle. One astronomer joked, "It looks like it has flat surfaces." Nobody laughed, because the more the data poured in, the clearer it became. Atlas wasn't just reflecting light. It was shaping it. as if parts of its surface were arranged, angled, oriented toward the sun in ways that didn't match any natural form. Some scientists compared it to a solar sail. Others whispered that it looked like segmented plating. A few insisted the reflections matched nothing in our catalogs at all. But all of them agreed on one thing. This was not the behavior of a normal comet. Even at great distance, the object acted like it was composed of interlocking pieces, some catching light, others staying dark, or shifting in an organized rhythm. And as it moved closer to the inner system, the sharp reflections grew stronger, like something beneath the dust was clearing, revealing, preparing. A shape was forming, a design hidden inside the glare. So what exactly is out there? What is arranging itself in the cold silence beyond the sun? And if these reflections are only the first glimpse of its true surface, what will we see when the dust finally falls away? As 3I our Atlas drifted closer to Perihelion, something new began to appear. Something faint, something fragile, something no one expected to see wrapped around an interstellar body. Edges, thin, delicate arcs glimmering in the sunlight, so soft at first that most observatories dismissed them as noise. A trick of the glare, a blur in the atmosphere. Maybe even stray dust floating across the lens. But the arcs didn't disappear. Night after night, they grew clearer. Not random shapes, not chaotic clouds, but smooth curves, gently bending around the object like the outline of something hidden beneath layers of darkness. In Hawaii, a researcher zoomed in on the latest image and whispered, "That doesn't look like debris." In Spain, another scientist stared at the same faint arcs and said, "It looks like structure." Because the edges didn't behave like broken rock. They didn't drift away. They didn't scatter. They stayed attached, orbiting, folding, shifting with the object's rotation. And then something even stranger happened. The arcs moved, slowly, purposefully, not tumbling like loose fragments, but spreading open, inch by inch, like panels unfolding in slow motion. One lab described it as flower-like. Another compared it to solar petals. A third said it reminded them of shield plating adjusting to the light. But the big question was the one no one wanted to say out loud. Why would something open in the vacuum of space? There was no wind, no pressure, no chemicals to trigger expansion. Nothing natural that could explain the gentle, controlled spread of those faint shapes. And yet, the arcs continued to widen, forming an outline that felt less like a comet, and more like a design, a structure emerging from the silence, something preparing itself, something responding to the sun, something waking up as it reached the point of maximum heat and light. Whatever was happening around Atlas, it wasn't random. And now, the world watched those unfolding edges with one burning question. If this is only the first layer opening, what will reveal itself next? For weeks, astronomers trusted the math, gravity, momentum, solar pull, the simple rules that guide every wandering body across the sky. 3I our Atlas had followed those rules perfectly, until the night it didn't. The first hint came from a small observatory in northern Chile. A technician noticed the expected position was just slightly off. Not by much, not enough to trigger alarms. Just a tiny drift, a fraction of a degree. But in space, a fraction isn't small. A fraction is everything. He checked for dust jets, the natural bursts that push comets around like little rockets. Nothing. No outgassing. No sudden flare. No visible plume. So he blamed the atmosphere. Then he blamed human error. But hours later, telescopes in Italy reported the same drift. Then Japan. Then Hawaii. Atlas had shifted course. It wasn't a wobble. It wasn't a bend. It wasn't a one-time stumble in its orbit. It was a clean, steady turn, a shift so smooth it looked almost deliberate. Every orbital model failed. Every prediction line collapsed. It was like trying to track a ghost with a ruler. The strangest part? The turn didn't match any natural force. No solar wind burst. No gravitational tug. No thermal pressure. Nothing in the environment could explain the motion. The object had simply changed direction. Scientists stared at their screens in disbelief, whispering the same question in different languages. What makes it move like that? One researcher compared it to a drone adjusting its path. Another said it looked like a probe using invisible thrusters. A third refused to comment at all. Because deep down, everyone felt the same cold truth. Things made of ice and dust do not turn with intention. They do not choose new paths. They do not steer. And yet, 3i, our Atlas, drifted gracefully away from its predicted orbit, as if following a new command, a new purpose, a new destination we couldn't see. If this object can change course on its own, what else can it do? In science, there are lines you don't cross, ideas you don't say out loud, thoughts you keep locked behind silence because the world isn't ready to hear them. But eventually, someone has to speak first. It began in a private video call, a quiet midnight meeting between a handful of astrophysicists from 3 different countries. Their cameras glowed in dark rooms, their faces lit by the cold blue light of data charts they could no longer explain. The pulse, the sharp reflectivity, the controlled heat, the course correction, for anomalies that might be dismissed alone. But together, they painted a shape no one wanted to recognize. One scientist finally exhaled and said it, softly, carefully, almost afraid of how the words would sound. It behaves like something engineered. No one responded, but no one disagreed, because deep down, each of them had already made the same connection, a quiet realization that had been growing inside their minds like a slow-burning fire. Natural objects do not pulse with perfect timing. They do not reflect light in metal-like angles. They do not regulate their own heat. And they definitely do not change direction with the grace of a guided craft. These are signs found in artificial probes, the kind humanity sends across the solar system. Except this one wasn't ours. And it wasn't from anywhere we could trace. One researcher whispered, if this is a machine, then who built it? Another added, and why send it here? The questions fell heavier than the answers they feared. Because if Atlas is a machine, then it didn't wander across space. It traveled. It navigated. It arrived. Its path through the stars wasn't a random drift. It was a journey, a mission with purpose. But purpose for what? Some believed it could be a scout, a silent observer passing through our system to study life in a distant star's backyard. Others suggested it might be ancient, a relic from a civilization long gone, still following instructions written thousands of years ago. And a few wondered something far more unsettling. What if the machine isn't here to observe? What if it's here to activate? As Atlas continued its quiet, impossible behavior, the secret conversation spread, from whispered calls to closed-door meetings, until the unspoken fear finally became a shared truth. If this is a machine, then something out there knows we exist, and whatever built it might be watching. Perihelion is the moment of truth, the moment when an object reveals what it truly is under the full power of the sun. And as 3i, our Atlas, reached that blistering point, something began to appear around it, something that made even the most seasoned astronomers fall silent. A ring, then another, then a third, not random dust clouds, not chaotic debris, but thin, delicate circles, arranged with a precision that nature does not usually offer. At first glance, they looked like halos, faint, dusty loops glowing with sunlight, drifting gently around the object. But when researchers zoomed in, the beauty twisted into something far stranger. These rings weren't drifting. They were moving, not spinning wildly like a normal dust torus, but shifting with slow, eerie symmetry, as if guided by invisible hands. Every arc had spacing. Every dust trail had order. Every movement followed a calm, rhythmic pattern, like something was shaping the material, holding it in place, arranging it. One astronomer whispered, "That looks like a structure." Another said, "It's building something." Because the rings behave like a shield forming in real time, tiny particles locking together, aligning their paths, creating a soft, shimmering shell around the object. A shell that grew thicker as Atlas absorbed the sun's scorching heat. Was it protecting itself? Was it harvesting energy? Or was it preparing for the next phase of its mission? The closer Atlas got to the sun, the tighter the rings became, like a cocoon closing around something fragile, or something dangerous. No one could explain the symmetry. No one could explain the timing. And no one could explain the way the dust responded to an influence no telescope could detect. But one question lingered across every lab, every observatory, and every quiet conversation. Is this a cocoon? Or a warning? Because if 3i, our atlas, is building something at Perihelion, then whatever comes next may not be meant for us to understand. The first pulse was strange. The second felt intentional. But the tenth felt like a heartbeat rising from something asleep. As 3i, our atlas, drifted beyond Perihelion, the pulses that once flickered like distant static began to strengthen. Brighter, sharper, closer together. Each flash struck with the precision of a ticking clock, as if the object had switched from wondering to waiting. Researchers dug deeper into the datasets, searching for meaning inside the noise. And that's when they found it, not in the visible light, but hidden inside the thermal readings. A pattern, almost invisible at first, buried in small temperature shifts. But once the team isolated it, everything changed. The heat wasn't rising randomly. It wasn't breathing anymore. It was sinking. Each temperature spike matched the timing of the light pulses, perfect alignment between heat and brightness, between inner motion and outer glow, like two signals speaking to each other. One physicist whispered, "This is not noise. This is coordination." Another added, "No natural body synchronizes like this." Then the realization came slowly, painfully, across every lab. The pulses were tightening, the gaps between them shrinking, the rhythm growing faster, like a countdown. No one said the word out loud, but everyone felt it moving through the data, that cold, electric feeling that something was preparing for a final moment. Some believed the object was charging up. Others suspected it was unfolding a final stage of its structure. A few feared it was sending a message, one that hadn't reached us yet. And still, the pulse continued to accelerate. Bright flash, heat spike, silence. Bright flash, heat spike, silence. Researchers plotted the intervals on a graph, and a line fell into a smooth slope, too perfect to be accidental. A curve that pointed toward a single ending, a final pulse. One scientist stared at projection and said softly, "Whatever this is, it's building to something." Was it activation? Communication? Transformation? As the countdown approached its final gap, telescopes across the world locked onto the object, waiting for the moment the rhythm stopped. Because if each pulse is a step toward something, then what happens when the steps run out? What awakens when the final pulse arrives? For months, the working theory was simple. 3i Atlas just wandered into our system by chance. A drifter, a visitor, a piece of cosmic debris passing through on a long, lonely path. But new analysis began to tear that comfort apart. A young orbital dynamicist in Germany was the first to notice it. She ran a simulation backward, rewinding Atlas' journey through space, and the path didn't scatter into randomness. It straightened. It aligned. It aimed. Not at the sun, not at Jupiter, but at us. Her colleagues repeated the simulation, assuming she'd made an error. But the same haunting curve appeared every time, a trajectory that didn't drift with the chaos of interstellar space. It corrected. It compensated. It adjusted, like something choosing a destination. Slowly, scientists began whispering the same impossible thought. What if it came here on purpose? But if it did, then why was there no message? No beacon? No greeting? No sign of communication at all? Instead, something else grew, something that felt even more unsettling. An electromagnetic bloom. At first it was faint, buried beneath solar interference. But each week, the signal thickened around the object's core, not in a broadcast pattern, but like a rising field, an expanding bubble of invisible energy. Not enough to harm anything. Not enough to reach Earth. Just enough to be noticed. It didn't speak. It didn't transmit. It simply existed, growing brighter, stronger, more defined with each passing hour. One scientist asked, "If this is contact, why does it feel like a test?" Another replied, "Because maybe it's not talking to us. Maybe it's watching us." Was Atlas measuring our reaction? Was it waiting for something? Or was a bloom a sign of what was happening inside, a process nearing its final phase? Whatever the truth, one thing was becoming painfully clear. This wasn't a lost object. This wasn't a mistake. And its origin, whatever it may be, did not drift blindly across the stars. Because things that wander do not aim. And things that aim usually have a reason. When 3IR Atlas began to leave perihelion, scientists expected one thing: the dust to fade, the rings to dissolve, and the object to return to the quiet darkness it came from. But the universe had one last reveal waiting, and it came slowly, almost respectfully, as if the object knew the world was watching. The dust around Atlas began to thin, drifting away in soft currents of sunlight. What was once a glowing cocoon started unraveling like smoke pulled apart by a gentle breeze. Layer after layer lifted, vanished, and exposed something that froze every observatory in place. A shape, not a rock, not ice, not anything known, but a frame, geometric, clean, deliberate, emerging from the last wisps of dust like a skeleton rising from a dream. Its edges were too perfect, too sharp, too intentional to be natural, and at its center glowed a cold green light, faint yet steady, pulsing with a rhythm that matched every anomaly seen in the months before. For a moment, no one breathed, no one spoke. Every sensor, every camera, every telescope stared at the same impossible truth. This thing had structure. Then, without warning, the frame rotated. Just once. Slow, graceful, silent, not tumbling, not drifting, but turning, as if acknowledging the sun, or acknowledging us. The rotation sent a thin ripple of green light down its edges, like circuitry waking for the first time in ages. Instruments screamed with readings that made no sense, sharp electromagnetic spikes, bursts of reflectivity, microsecond pulses in the radio band. And then, it stopped. The frame slid back into the dark, letting the dust fold around it once more. The glow dimmed. The signals faded. And Atlas returned to silence, drifting outward as if nothing had happened at all. Scientists replayed the footage again and again, searching for an explanation. None came. The shape shouldn't exist. The light shouldn't exist. The rotation shouldn't exist. But all of it did. And now, the world waits. Was that frame a message? A malfunction? A warning? Or the first breath of something waking up between the stars? If this was the end of the mystery, then why does it feel like the beginning of something far bigger than us?